all very much for showing up for the September GGDA meeting. Yeah. So for those of you who don't know, the Georgia Game Developers Association is a GGDA. We represent everybody who makes games in Georgia. There are more than 80 studios making games in the state. We have now one of the top 10 largest states for game development in the country. And we'll be putting on the Southern Interactive Entertainment and Game Expo next month. If you've never been to a GGDA meeting before, and there's one or two of you who haven't been to one before, we do them the second Tuesday of every month, except for next month because that's when we have Siege. We look forward to all of you joining us at Siege. It is the 10th year of what is now the largest professional game development conference in the South. It will be running from October 7th to 9th. We have sessions on programming, design, audio, art, the whole business side. We actually start on the 7th with an investment conference. We just accepted all the different companies. So if you want an investor, sorry, you got to come back next year. But you can come see them pitch and see what kind of games they're looking to make and what kind of projects the investors are looking to become involved with. This is the 10th annual Siege. If you want information about it, please go to ggda.org, Georgia Game Development Association.org, and sign up for our newsletter. We've already announced that Nick Lang, a senior producer at Turn 10, working on some of the best sports games out there, is going to be one of our keynotes. We'll be announcing our second keynote, a really big name, later in this week. I was actually hoping I'd be doing it tonight, but they said hold off a couple days. So one of the other, we've got a lot of different things happening in Siege. A lot of it's panels, a lot of it networking events, some of it's parties, yes. We have a game design improv. This year we're also going to be having a Unity certified developer exam. Who here's worked in Unity? One or two of you again. Okay, excellent. So the Unity certification program is fairly new. They introduced it earlier this year, and this will be one of the earlier tests of this in the South. So if you want to be certified as a developer, he'll tell you that you actually know Unity. This is the best way to do it. It's a $250 test, October 6th at Siege, but you get a 25% discount if you're a GGDA member, which is only $40 for students. So right off the bat, if you're going to take the certification exam, it's a significant saving. Yeah, come on, you're all tech students. You figured the math out right then. Come on. This isn't UGA. Sorry. The UGA contingent. All right. So we've got a lot of things going on. We're doing our second annual Game Studio Smackdown. Yes, we focus on making games, but sometimes we play them, mainly so we can rub it in that we're better than the other game developers in town. Last year was a big Halo competition. This time it is Rocket League. I don't know if the second game has been announced yet, so I'll be quiet about that for now. So the Siege is up in Marietta, so please be sure to check out the website, get information on that. There are a number of other things we support in this town. There's a Unity meetup. There's an Unreal meetup. All of this information you can get off of our website. For Unity, we're actually going to be doing classes to prepare people for the certification exam. Josh over there is will be teaching it. We're probably doing one October 2nd up in Marietta. So again, if you're interested in taking the certification exam, want to make sure you're up to speed in time, talk to Josh, talk to myself, and we'll get you set up and ready. There are a number of other big events coming up. Our Middle South Georgia chapter is both having a Pokemon tournament, depends if we're talking about our, September 24th, but they're also having a meeting talking about various game industry disciplines. And you can catch their live stream just like they're able to catch a live stream from our Atlanta meetings. For those of you who are interested in esports, we have two very significant esports events coming up. In November, there's a studio here called Blue Mammoth, does a game called Brawlhalla. They'll be doing their world championships I believe up in Galleria. You can talk to us about becoming involved with that. In January, Hi-Res Studios, which does the game Smite, is having their, I believe it's the third World Championships. Their first esports event was actually done at a Siege. This will be their third World Championship at the Cobb Energy Center, and we'll be signing up people to help them work with that, attend, and so on when you all come out to Siege. One of the great things about the GGDA is that it really is a member organization. I want to point out a couple of members very quickly. Jake Corley outside signed you in. He's our volunteer coordinator. And if you want to come volunteer to work at Siege, talk to him after the meeting. Chris Eiserman over there runs our expo hall at Siege. We've got a lot of good companies. And we have a huge indie cluster area where the indie game developers show off their titles. I know there will be some Georgia Tech students involved in that project. If you work in audiovisual at all, we have an AV team headed by Matt Franklin, James Ridgway back there. We'll be looking for AV volunteers to help out with Siege. Any of the GGO, and Jesse Jacobson somewhere over here. There we go. I was looking, I seen one Jacobson, not the other. Runs our programming track at Siege. So GGA has made up a lot of members. The members make it happen. I know there's some members here who have announcements. So Tariq, if you'd like to start really quickly.
Yeah, I work on the second floor at the ATDC down here at a tech startup company. We are optimizing the internet for real-time applications, starting with video games. We're looking for testers who play Overwatch or League of Legends, and if you want a faster, more stable internet while playing, come see me or check out our website, haste.net. Thank you.
All right, I know there's some other announcements.
Hi, I'm Judy Stowe at GGDA High School, and I'm here tonight to look for industry helpers who might want to partner with our school. We've started our first game design class this year, so we're trying to get it up and running and need some support. So if you'd like to come talk to me up here.
And where's the school located?
Marietta High School.
Oh, right down from our from Siege. Excellent. Okay, I believe other announcements. Yes, Joe, of course.
Since you glossed over it,
I gloss over the time.
the indie cluster this year will have the first ever Sylvia Award. I guess we're calling
It's
it.
the excellence in independent in indie game design. The
Excellence
silver.
in indie game design. So there will be 3 prizes this year, monetarily, actually. So, and should I say the monetary amount? Get them excited?
$500 in total prize money
Yeah, $500 in total prize money.
for independent games, and sponsored by Puzzles by Joe, whose games you should check out if you didn't before the meeting.
Sure. That's irrelevant, though. Really. It's more about bringing the games to the indie cluster.
Yeah, be irrelevant in the room.
Having fun.
You want Kartik to talk about VGDev now, or?
Yeah, go for it.
Yes, hi.
Put you on the spot.
Hi, I'm Kartik. I'm a Georgia Tech student here. I'm also president of VGDev, which is the Georgia Tech Game Development Organization. Got my vice president over there, Neil. We make games. We make like 6 to 7 games every semester, and we showcase them at our campus demo at the end of every year. It's going to be November 18th this year. Check out our website, vgdev.org. You can see all the games made by our students, and you can see what our students have worked on. All of them are incredibly talented people, and it's a great way to network with other Georgia Tech game developers.
Excellent.
One thing that he didn't mention is that there's copious amounts of pizza at the campus demo.
Yeah, you
so
guys took
come
out about
check
20
it out.
pounds tonight.
It's a win-win. You get to play games, you get to eat pizza.
I'd also like to point out a representative from the Microsoft Perimeter store back there. We partnered with Microsoft Perimeter a number of times. We do game tutorials. Our Advancement in Women Games chapter has run a number of sessions out there teaching people how to make games. So if you have interest in Microsoft products in general, and they're selling the HoloLens, go talk to him. Oh, everybody's attention suddenly went on you at that point. Go talk to him. Any other announcements of the crowd before I turn it over to, yes?
Real quick, Siege leadership, if you have seen our promos that have been going up on YouTube. First of all, we have several of those waiting to go live. We're also making some more tonight, so if you want to give a testimonial of about 60 seconds, we have stuff set up after this for that. So talk to me, talk to Ryan. Where's Ryan?
Oh, hi.
Yeah, talk to one of us after.
And with that, I will turn it over. I'm the executive director of the Georgia Game Development Association. I'm Andrew Greenberg. Feel free to talk to me, come to me with any questions you might have. Our Athens chapter president is here. And I'm now glad to turn it over to our Atlanta co-president, Ryan Menz.
Hey, what's up? Like I said, my name is Ryan Menz. I'm the Atlanta co-president of the GGDA, but I'm pretty much just doing what he tells me to do. He's the real genius. But I'm also one of the Microsoft student partners here for Georgia Tech. There's going to be a team of 3 of us this year. Well, what that means is that we're actually sort of like campus ambassadors for Microsoft. So if you guys want to keep in touch with what Microsoft has going down, you should totally follow us on social media. So that's facebook.com/group/what this says. And then hit me up on Twitter if you do that, at Georgia Tech MSFT. So yeah, if you don't want to miss out on that, hit us up, because we'll be posting a whole bunch of stuff. Not spammy, we'll keep it low key. One thing, if you guys aren't on here already, go ahead and sign up. I've got a couple goodie bags I'm going to raffle off RNG's style at the end. So, we're going to move on to a few last announcements before we turn it over to our speakers. So, for students interested in Microsoft stuff, GG Web Dev is hosting Microsoft tomorrow in Howie L4, 6 p.m. for a Microsoft Azure workshop. This is the blurb. We will present an overview of Microsoft's cloud platform and an introductory workshop on how to make a web and mobile apps using Microsoft Azure service, and free food and drinks. Also bring your resume because recruiters are on campus. They're going to be raffling off an Xbox One tomorrow at that event. Also, Microsoft Supply Chain is on, sorry about that. Microsoft Supply Chain is also on campus as well. So they're doing 2 events coming up. Tomorrow, they're doing a Surface case study, so that's at 5:30 to 6:30. Register by Tuesday by sending an email to MSCC, sorry about that, MSC case study at Microsoft.com with your name, major, and expected graduation date, and your GT account. If you guys are interested in that, hit me up after the meeting and I can give you that email. And then on Thursday, they're also doing a presentation at 5:30 to 7:30, and that's going to be a presentation with networking, and DM Smith building in the main lecture hall. So that's all I got, so let's go ahead and turn it over to our speakers. And if you guys want those links at the end, just hit me up as well.
Okay, so hi everyone, I'm Sasha and I'm a part of the Entertainment Intelligence Lab with Kristen over here. We're working on a couple of mixed reality games of looking at the AI perspective as well as how to actually interact with the world in mixed reality. So just to give you an idea of what we're doing, so this is really an exciting time for me. I'm a huge sci-fi buff and this is the first time that sci-fi we've actually been catching up with sci-fi. So we started hearing about mixed reality and holograms in sci-fi back in 1893 with Jules Verne. And then it was again referred to, we looked at holograms that were indistinguishable from real life in Asimov in 1942. Eventually, the television and film media caught up with it. We have everything from Matrix to Stargate, and now Black Mirror is basically coming true with the HoloLens. And so, if you actually look at it, this is pretty cool because you can see even Back to the Future. Oh yeah, I have really old references, so for everyone who hasn't seen them, these are movies you should watch. But so Back to the Future 2 back in 1989 described a world where you can see Marty kind of wearing what looks like the HoloLens. And again, you see him with this giant hologram shark coming to bite his head off, which is really great because that's kind of what we're hoping mixed reality is going to look like with the Magic Leap, although full disclosure, I don't know how much of video editing went into that particular video. So what is mixed reality? Mixed reality is basically the merging of real and virtual worlds to give you new environments where the digital world can interact with the physical world and where these objects will coexist in real time. It's actually a mixture of augmented reality as well as augmented virtuality. And so now I used a whole bunch of random terminology that no one here is probably familiar with, so I'm going to pretend you aren't and try to explain that out to you in the first minute. So what exactly is mixed reality? When we look at it, mixed reality is divided into 2 scales. First, on the bottom axis, we look at the reality-virtuality continuum, where it's divided into the real environment, augmented reality, augmented virtuality, and the virtual environment. So the real world we're all familiar with. But what are the others? So augmented reality is basically incorporating virtual elements into the real world and being able to interact with these virtual elements and real elements. Augmented virtuality is incorporating the real world into the virtual world. So for instance, if you've ever used an accelerometer on your phone, if you've seen 3D live video within a video game or anything like that, that's all augmented virtuality. And then finally you have the virtual environment, which we're all familiar with almost every game that we use. On the left axis, it's actually divided into the mediality continuum. So the mediality continuum goes from diminished reality to severely modulated reality, where you look at how much of the world is being obscured or being enhanced using these devices. So diminished reality could be anything from monitor-based to looking at the world through your phone. And so you're looking at the real world and a little tiny part of it is augmented with the virtual world. And severely modulated reality would be where like the HoloLens or Magic Leap come up, where you're looking at the entire world through a head-mounted display and a head-mounted device. And so if you look at examples, because that kind of makes it easier, we first have the real world, that's fine. Then within augmented reality, we have in increasing order. First you look at it through your phone, then you look at like Google Glass, where there's some amount of virtual augmentation of the real world, and then finally Hololens, where it's a lot more incorporated. Here you can actually interact with the real world, it affects the virtual world, and the virtual world affects the real world. We also have augmented virtuality, which could be anything from Myst, a really awesome game, again back from the 90s that you guys should play, where you have within an entire virtual world some amount of streaming video from the real world. Or Temple Run, where you're using the accelerometer of your phone, or even the Wii. And finally, we have the virtual environment, which starts with anything from the Oculus, where you can see and you're completely immersed in this virtual world, but you can't really interact as much with it, to the HTC Vive, where not only are you immersed in this virtual world, but you can actually interact with all these elements within your virtual world. And so mixed reality kind of falls anywhere between the real environment and the virtual environment, and is a combination of these. And so we've seen mixed reality in video games recently getting a lot of media hype, with Young Conker first from Microsoft, where surface detection allows young Conker to actually fall off surfaces with a little dizzy animation, or jump on sofas if it recognizes that that's a sofa versus like walking straight on a table. Or even with recent the Yu-Gi-Oh build, which came out on YouTube, which was pretty interesting, where you can now actually have these characters animated, and hopefully they will be battling each other soon. And
that's on GitHub if you want to pull it down and look at it.
Yes, which is really cool. And so before I come to what kind of platformers and research there is out there, I'm going to hand it off first to Kristen. So,
okay. All right. All right. So hi everyone. I guess I'm Kristen. This is Sasha. This is James. I guess we didn't really introduce ourselves, but we're sort of giving this talk in pieces tonight. And tonight I'll be talking a little bit about what it's like to actually design games in mixed reality. So I'm Kristen. I'm normally a PhD student here at Tech. I do research in artificial intelligence and games. I'm also an independent game developer working on this game called Elsinore. And the reason I'm here tonight is because last summer I spent a couple of months working at one of the internal game studios at Microsoft, specifically making games for the HoloLens. So disclaimer, I'm not here as a representative of Microsoft tonight. Most of the stuff that I was working on there is completely secret, so please don't ask me about it and I can't talk about it. But, sorry. But what I can talk about is sort of in general what so it's kind of like VR. So it's this thing, you can see it right here. You can put it on your head, you can move around in first person. Your neck is effectively like your camera controller or your joystick. Your eyes are now your mouse cursor or your pointer. It's kind of like the Kinect. You basically have a Kinect strapped to your forehead. You can use natural user interfaces and hand gestures. So a lot of what we know about motion gaming comes into play here. And it's also kind of like your tablet or your phone. So anything that's related to augmented reality or mixed reality on your tablet or your phone, a lot of these design principles can still carry over to the device, to the experiences that you're making on a device like the HoloLens. So let me talk a little bit about physical comfort. So, one of the biggest differences between this device and something like the Oculus Rift or the HTC Vive is that you're wearing an entire computer on your head, which means that it's surprisingly pretty heavy. And it means that your neck is now effectively your joystick. And if you have experiences that involve you looking around constantly, after a while, this is going to get pretty stressful. And so unlike a VR device, this is a full computer, it's running on your head, it can get pretty hot, it can get pretty sweaty, and it's also pretty heavy. I personally can't wear it for about more than an hour and a half of looking around constantly without feeling kind of achy back here. So just something to think about when you're thinking about experiences on this device. And again, other things, you sort of have to worry about, people's actual physical build here. I'm pretty short compared to the average person using this device, so I'm constantly looking up. So if you're thinking about making an experience, you want to make sure you're thinking about, people of all different heights and sizes being able to use it. And again, the device takes advantage of a lot of things involving natural user interfaces. So people still aren't adjusted to motion gaming the way that we are adjusted to using a mouse and a keyboard. So yes, it would be really cool if I had a game where I was constantly shooting force lightning out of my hands the entire time. But after about an hour, my hands would be pretty tired because this is not really a natural thing that I've been doing for most of my life. So for the rest of this talk, I'm sort of going to go ahead and use a running example. So let's say, I've thought about all these things. I want to make an experience for the HoloLens, or something like that. What do I want to do? Well, so we have a virtual character. What kind of experience do we want to make? So I thought really hard about this and what's really popular right now. Well, let's try and put Pokemon on the HoloLens. And I'm sort of going to use this as a running example to walk you guys through what you might run into when you're developing for this device. So let's see. We've got Pokemon. This is pretty cool. I want to make a Pokemon game on the HoloLens. You've seen YouTube videos of people basically putting Pokemon Go on the HoloLens. Go check out YouTube, it's great. But let's say we haven't looked at any of that. So we just put a bunch of 3D holograms of Pokemon. They're running around our world. What are the things that we're going to start running into first? Well, the first thing is you probably hear a lot of people talking about the field of view. So if you read any early reviews or early impressions of HoloLens, a lot of people seem to be saying things like, oh, the field of view is really narrow, or oh, you get used to it after a while. But the biggest question you might have is, how does this affect gaming? So the way that I like to think about this is, yes, there is a field of view. It's basically a window that's sort of cutting out into cutting holograms off sort of at the edges. And in many ways, think of it like having a tablet's view in front of your face. So you can only see what's within that sort of tablet-sized view in front of your face. Which means that all of the really good design practices that we understand for making games on augmented reality on things like your phone or your tablet apply here. So these are things like putting visual indicators along the side of the field of view to sort of direct players, or adding 3D sort of breadcrumb trail effect to the device. But the device, like HoloLens, also gives you a lot of different affordances like spatial audio, which is not really something that we've ever really seen before up until very recently with things like VR. So what does this mean? Well, so I have this experience here. I have a user. There's a Pokemon somewhere in the room. I want them to find it. The field of view might be a little bit narrow, but here's some ways that I would go about it. So here's a field of view. It's basically a box, and you can see within that window. This is not an accurate representation of what the actual field of view is like. But you can do things like you can start adding indicators. We know the Pokemon is somewhere off to the left, so we can start putting things on the edge of our screen. We can actually make a 3D trail to direct the user's attention to the Pokemon over there, or we can do other things. So it can call out to us, and then we can take advantage of spatial audio, and now we're directing the user in a way that is very natural, but it's not really like anything we've ever been able to do before up until VR and all this kind of stuff. So that's one way to think about field of view. I'm going to talk a little bit about natural user interfaces. So here's the device. Obviously it doesn't look like it has a controller. It does ship with a clicker. It's just a button. But again, a lot of your interaction with it is going to involve using your hands. So what do you have afforded to you? Well, as I mentioned before, there's this whole idea of gaze tracking. So it turns out that using your gaze or the orientation of your head is perhaps one of the most precise ways to interact with the world. It's basically your equivalent of a mouse pointer here. You also have things like hand and gesture recognition. So if you've watched any of these videos, you see people holding their hand out and air tapping or blooming to bring up the home menu. And then there's also other things. So there's a lot of stuff with like voice recognition. Now, if this had been like 10 years ago, people would have been like, oh, you're talking to your device, that's really awkward. But we're at a point now where people are getting into like the idea of a personal assistant. You have things like Alexa, you have things like Siri. So talking to your device is no longer this sort of strange thing that it used to be, which means that we can really take advantage of stuff like this even in gaming. And things like, calling out to summon your menu to you is a really great way to like not lose track of your virtual hologram, for example. So going back to the Pokemon example, here are 5 ways to do the exact same thing, all using different natural user interfaces. Let's say I want to catch a Pokemon. Well, I can use gaze tracking. I can, track the gaze. I can keep my gaze focused on the Pokemon for X number of seconds, and then I've caught it. Or I can, you do the same thing, except now instead of asking them to hold their gaze for a certain amount of time, I can have them use the clicker or, some hypothetical controller that might eventually hook up with the device if they get, Xbox controllers working with the device. Or you can actually ask people to sort of move their hand around and air tap on top of where they think the Pokemon is and click on it. You can actually try and incorporate throwing gestures. So maybe you want to have people actually throw a pretend Pokeball at the Pokemon. Or you can use a combination of things like gaze tracking and voice. So it's like you focus your gaze on the Pokemon, it's like, hey, catch it. And you can catch it. That's cool. So these are all different ways to do the same thing. And the thing about it is that we haven't really explored this. And so one of the cool things about working with a piece of technology like this is that we're in a position where we can sort of invent what it means to interact with the device and come up with useful ways that are both very comfortable and both very engaging for the player to do really cool stuff with it. So now I'm going to talk a little bit about, physical spaces as levels. So now that we've got this game, now we can sort of like look around, find Pokemon, catch Pokemon. And so how do we incorporate take the virtual elements of this game and put them in the real world? So we can do things like, well, we want to place content in the world. How do we place content in the world? Well, we can find flat areas in the world to do it. And you can do things like trying to recognize your room. I'll have little diagrams and illustrations of this so you guys can take a look at it. And there's a lot of work being done in computer vision right now about what it means to recognize a room. How can you tell this is a kitchen versus a bedroom? Can you tell that this is a chair versus a table or something like that? And we can incorporate all of this cool stuff into our games, which is not something we've seen before. And then one last thing to think about is how do you create feedback between the virtual world and the physical world? So it's like, I'm putting virtual elements in the physical world. Can I adjust the physical world to change the way that things are interacting with my game? So let's go back to the Pokemon example. So this is a very, it's a sterile room. This is what I was showing before. But rooms actually have things like furniture in them. So let's take furniture into account. So what does this mean? Well, when you're thinking about incorporating the real world into your game, where do you want to put the stuff you're going to be interacting with? Well, one thing you can do is you can look for flat areas free of clutter. That's great. This is people's attention is drawn to stuff that's empty. It's also good for the device. Hololens, for example, will give you a reconstructed 3D mesh of the world that it's seen around you, but there's all sorts of cool tools and plugins that'll help you find planar surfaces in this room, which are great for placing content. And then there's all sorts of stuff on top of that, which will let you find things like walls. So you can identify the ceiling, you can identify the floor, and you can start building rooms and building spaces to bound and put your content in. So going back to the Pokemon example, what does this mean? Well, I want to make my game better. I want to make it a little bit more interesting. So I want to be able to do things like Zubats are clearly flying Pokemon. They're bats. They should hang from the ceiling. So now if I know where the ceiling is, I can start putting Zubats on my ceiling so that they can come down and ambush me and be really annoying. And I can do things like, I can put Diglett on the floor, and I know it will be the floor and not the wall because, I'm now able to detect where the floor is. And this seems really natural, right? Because it's not natural if Diglett comes out of the wall or something like that. It's a ground Pokemon.
Get off the table.
Yeah, well, hopefully, we're sort of at the point where we can tell where the floor is, and we can also tell where tables are, so hopefully we're putting it on the lowest plane on the floor. We can also do other things, like we can start incorporating objects in the real world. So while room recognition is still really new, and there's a lot of people working on this problem, what can we take from the real world and start putting it into our game? So here's something that's really simple, that's kind of fun to think about. You get color data back from the HoloLens or mixed reality devices. And color data is notorious because it's sort of sensitive to luminosity and intensity and other stuff and time of day. But you can do things like, well, now you want Pokemon to camouflage themselves against different parts of your room. And this brings up really interesting questions. So here I have an orange rug. I'm going to hide a Vulpix on my orange rug. There's purple cushions on my couch for my Rattata. But what if I was looking for a Pokemon that was pink? Would I, now all of a sudden I can do things like, ask my players to go run and find an object that's pink, put it into the room, and it'll spawn different Pokemon for them. And this is really cool. So now we're incorporating elements of the real world into the game, and we're changing the game, and this is creating a really cool feedback loop where like the virtual world and the real world are interacting in really cool ways. So eventually we could sort of extrapolate this to all kinds of cool things like, I want to be able to identify bathtubs. So if I go into the bathroom, I can catch water Pokemon, and if I go into the kitchen, I can catch fire Pokemon near the stove and stuff like that. So we can go on about this, but we're running a little short on time. So here are just a couple of things to think about in sort of a summary of what I was talking about, which is, here, physical comfort is really, really important in ways that we're not really accustomed to thinking about making game experiences before. Because, now the player is no longer static. They're not necessarily sitting at a couch or a computer. They're actually potentially up, moving around. We have to take physical constraints into account. So and at the same time, this device is it has a lot of the affordances that we're familiar with. It's like VR, it's like mobile, it's like augmented reality. But there's all sorts of new hardware things like spatial audio, like all this gesture recognition and this voice recognition that we can combine to overcome what we think might be potential limitations of the device. And there's other things, like thinking really hard about the way that your physical space and your virtual space should interact with each other, because all of a sudden, we're really good right now at coming up with virtual experiences. We can build really cool worlds, not just in VR, but like that's what games have been mostly up until this point. But now all of a sudden we have this huge like physical world full of stuff. How do we combine it with the virtual space in ways that are really interesting? So that's all I've got to talk about. I'm going to pass this on to James, who's actually going to be talking about what it's like to, like, the sort of the nitty-gritty details of what it's actually like to develop for this device. But, yep. Yeah, so thanks. So if you have any questions about this, just feel free to come up to me after the talk, and I'm happy to talk to anyone. Oh, go for it. Here we go.
There we go. Okay, so what I want to talk about is a little bit about the dev tool chain. If you guys are clearly into gaming, I want to give you a flavor of what that's like developing for the HoloLens. And just a preview, it's a lot of configuration, very little coding for the most part, and a lot of waiting around. But when you get the results, it's really worthwhile. I'm also going to present some scenarios that you might want to use this for. Okay, and some quick disclaimers. So my name is James Ashley. I work with Microsoft. I do not work for Microsoft. I do not speak for Microsoft. I especially do not work for the HoloLens product team. They asked me to say this, by the way. I do not speak for the HoloLens product team because they're totally awesome and I just get to play with what they do. So a bit about the hardware first. Basically, this is a conglomeration of a lot of really amazing hardware. The first thing that you'll notice is the waveguides. So that's the clear lenses in front. You've got mini projectors on top that will send basically images into the glass and then diffract them back into your eyes. And that's how you get this really fantastic virtual objects on top of real objects. And of course, since you've got two lenses, it's stereoscopic, so you have a sense of depth also. That's sort of the heart of the illusion that the HoloLens creates. But then it's got some other stuff which is really amazing too, and that's all the sensors. So you've got a depth sensor, and if you're familiar with the Kinect, that's basically the Kinect sensor. And it does the same thing. One of the big things, if you play with Kinect, is surface reconstruction. You could spin the Kinect around room, it'll try to rebuild it for you and then stitch it all together. Well, that's exactly one of the core things that the HoloLens needed. It needs to be able to scan the whole room and figure out where all the surfaces are, as we were talking about before. Figure out where your flat surfaces, where your walls, where your ceilings, and so on. It's also got 4 black and white cameras, which are used for basically locating you inside the room. So it's using some form of SLAM or PAM. And these are algorithms I barely understand, but it's to figure out contours in the room, to figure out your relationship with them. And then as you move, to hang on to those relationships, so that objects that you place in the room appear to stay static even as you're moving around them. Again, one more really complicated thing, and then that's being meshed together with your surface reconstruction. That's all being done on a chip called the HPU, the Holographic Processing Unit, in order to get really fast processing. That's also doing a lot of the gesture recognition for you too. It's got a light sensor to figure out what the ambient light is like. You've got a color camera on there, which is just a handy thing to have. You've got spatial audio outputs on the sides of your ears. And this is really a different kind of binaural audio. It's using very complicated models in order to basically figure out how do sound waves come into your ear from different directions, from behind you. And it's a lot more than just making it soft and loud in each ear. It's doing some really complex things in order to fully create the illusion. Very similar to the stereoscopic illusion, the binaural illusion of 3D audio. So lots of crazy things. So, and by the way, part of not really having NDAs, I can talk about these things, but 1 in every 10 things I say, it's probably a lie, so just warning. The way Microsoft is positioning this thing, which is interesting for this audience, is not necessarily as a gaming device. It's a $3,000 dev device at this point, and there's also a commercial device available. So it doesn't make a lot of sense for people to buy devices that cost $3,000 to play games, so they're not really marketing it as such. Instead, they really want to push it into the enterprise. But we are going to end up on games. We're going to land there because that's a great place to be. But let me go through some scenarios of other things you could use it for. There's Trimble in Atlanta, actually did one of the early prototypes, and they're using it to do 3D modeling. It makes a lot of sense in their world where you need to be able to visualize what you're working on. But what would be amazing is if it were virtual and you could walk around it, and you could even sync up people on the West Coast and East Coast looking at the same thing. And then you could scale it. And then if you had to make changes, you could make changes and basically look at it again 3 or 4 hours later after all the changes had been made. That's a really great use for it in architecture. Design. So you've got CAD software actually being developed right now. No idea when it's going to come out exactly, but there have been videos for it where you're going to be able to do 3D modeling with your HoloLens. And that seems like another really effective use for it. If you're going to be building 3D models, why not also do it in 3D? Does it make sense to be building 3D models in 2D? Not really. Engineering is another one. This is actually one of the big pushes. The notion being that you can build something in CAD, push out your 3D model, drop the poly count, but add some animation so that engineers can actually look at how things work, at the size of it, and get a real sense of what engines and other engineering devices will act like. And always, these are intended to be aids. They're not the main course, but the idea is that these are aids to doing things that we do today that will allow us to do it much better. I can see some of you are impatient. I swear we're going to get back to games eventually. Education is another really big thing. Case Western, I believe, did one of these. And the notion is, just like VR is very immersive, mixed reality can be extremely immersive too. It grabs your attention. You're able to interact with it in very interesting ways. And the notion is that this may be a really fantastic way to help people learn things that are otherwise very complicated. Telecom. This is actually a project done at Microsoft Research using the HoloLens, but also using a lot of really nice 3D sensors and color cameras. And the notion is that we can reproduce an image of somebody else that we're taping in 3D and project it into their world, either at real life scale or in this case, mini scale. And the really nice story behind this, it's a guy working at Microsoft talking to his daughter in their home country. How more awesome can you be?
Need your help, Obi-Wan.
Yeah, exactly. Exactly. Lifestyle. So this is when the Microsoft stuff stops being real demos and starts looking like something done in Adobe Effects. But it's a great idea. This is actually based on another Microsoft research idea called Illumaroom, or I think that's it, where instead of just watching TV, you can extend your TV set and have interactive objects in the room with you. And they've done a few concept spots like this, where the notion is, let's make this part of everyday life instead of just something you do for an hour or two at work. Why can't you just wear these all the time? Well, there's a reason you can't wear these all the time. As Stephanie was talking about, it starts to hurt after a while, and probably your nose here is going to hurt long before the battery ever wears out. But one of the things we can look forward to, and one of the points of putting out a device like this, a developer kit, is that we could start exploring scenarios that make sense and sort of wait for prices to drop and wait for the technology to get smaller so that we can actually have stylish Google Glasses that do the sorts of things that Google Glass was supposed to do but didn't. And here's one of my favorites that when I was in marketing, we would push this concept all the time. Why not have mixed reality in retail and be able to wear it outside with your Versace HoloLens glasses on, where you can see somebody walking by, you admire their coat, so you tap on it, does a scan, syncs it up with the store where it came from so that we can find the price and some other information about it, find out what the reviews are, and if we like it, we can actually complete the transaction right there and purchase that awesome coat that we just saw on somebody else, which in marketing, this is a dream because impulse buys would just be amazing right now. So nobody has numbers on this. Let's hypothetically put a bookmark around 5 years. Why not? But what about games, right? What about games? Well, one of the really interesting things about the HoloLens is when it came out, it had a bunch of demos, and all the demos were games, even though they're also marketing it as this is really intended for the enterprise, right? So it's a slight mixed message, but I think it's also really a fascinating one because in general, I think what we've noticed over the past decade or so is that games always lead on interactions and graphics and things like that. If there were no games, we'd still be working in Windows 95 level graphics, right? Because nobody would ever say we need anything else. But we do. We need things to be interesting. We need transparencies and lots of other cool things. So with the HoloLens, they actually came out with a really fantastic slate demonstrating different styles of games. You've got a sim game with their Minecraft sample, which actually has never been released. It's only been shown on stage. I do not know the story behind that, but it's an awesome demo on stage. You've got a platform game with Young Conquer, where it's actually finding the planes in the room and jumping on tables, jumping on mattresses, on couches, and so on. Awesome. Then this is the only one that's not Microsoft. It's by a guy named Stephen Chu, who put it out on GitHub. And he actually created a collectible card game, which everybody realizes is what you really want to do with mixed reality anyways. So he tried. This is a game called Fragments, which is an adventure detective game. And then you've got a first-person shooter with RoboRaid. Yeah, so it kind of runs the full gamut and really demonstrates that if you're interested in doing games in mixed reality, you actually could. And it covers most of the style of gaming that we like to do. So now that we put everything out there, all these different styles of games, and consider this as something of an experiment, right? People just said, can I actually do this? I'm going to go do this. And they did. And it shows up in the HoloLens demos. But we pull all that together, and there's some learnings we can get out of it, one of which is because of the spatial mapping that's always going on, the game changes and adapts to every room that you're in. So each room changes the game space that you're playing in and changes the whole experience. For instance, with Young Conquer, it's a platform game, right? Well, if you've got different tables in different rooms, the platforms you're playing on are going to be different, which also means some rooms are going to be easier than others, and some people's houses are going to allow you to level up much faster than other people's houses. Another interesting correlate to that is every game is a custom game for you. And one of the great examples is this game Fragments, which is an adventure detective game by a company in France. I want to call them Restropo, but I have the feeling that that's actually the evil video game company from Assassin's Creed. So
I think it's Asobo.
Asobo, that's it. I don't know if they're evil or not, but what they did here was they had a very simple technique. They figured out we can distinguish between sofas and couches. So what we're going to do is when you scan the room, we're going to notice if it's there. And then when you have to talk to somebody else in the game, if there's a sofa, we're going to have that person sit on the sofa. If there's a chair, we're going to have them sit in the chair. And if there isn't a sofa or chair to sit on, we're going to have them stand. So that's a fully adaptable game, and it's just utterly brilliant because when you see it happens, it freaks you out. To have a VR person actually sitting in your living room appropriately, right? Okay, and so what that means, and Microsoft's actually used this phrase more or less, every room of your home is going to be a new level of your game. You can see sort of the excitement of that. If you can, most games now generate their levels based on algorithms, sort of randomly and so on. But what if you also throw in this aspect of it where it adapts to whatever's already in the room? It makes games highly replayable in that case. Because if you get bored with playing in your house, you just go to your friend's house and you get to start all over again. There's some downsides to this though. Scoring no longer makes sense, right? Because your house may be a lot easier than your friend's house and vice versa. So how do you really compare people's gaming abilities? You can't anymore. So we got to find different ways to create incentives for people to play games. And this is actually kind of interesting and fascinating because it breaks the mold of how we develop games now, right? We depend on scoring systems. So this is a whole class of games where you have to find a new way of building the game without a scoring system.
Reaction speed?
Maybe. And interactions. Actually, the interactions that are available are pretty awesome, but and it feels awful to ever say that they're limiting, but they slightly are. So you've got the cursor and you've got the air tab. These are based on mouse point and click, basically. And you've got voice commands, which are awesome. If you've ever played a game with voice commands, it's great. But it tends to be able to augment a game, never be the full interface for it. And so everybody's still trying to work around that. What makes sense as an interface for these sorts of games? And we have some things that work now, but everybody's sort of trying to figure out how can we do that even better. And there's also a fallback. This came out with the most recent update to the SDK, where you can hook up your Xbox One controller to the HoloLens and play that way. So again, basically we're still very much early days, figuring out the adventure, figuring out how things work. And there's plenty of opportunities for a lot of people to discover new things and basically be the first one to come up with something, right? So let's talk about how you can develop for the HoloLens itself. So in case you didn't know, now you know, it's all based around Unity. You can do Direct 3D also, but man, Unity is a lot easier than trying to do that thing. There's some complications though, because even though you're using Unity, you're going to be exporting it to Visual Studio, which again, fortunately, is free also if you use a community edition, because we need to wrap up your Unity game inside a UWP shell in order to deploy it to the Windows Store and provide extra security. So UWP is basically Microsoft's answer to deployment and safety and security. You also probably want to have the HoloLens toolkit, which is out on GitHub, and that provides a lot of extra scripts and so on to do very simple things like provide you with an array of flat planes and provide you an array of vertical planes, which can be really handy if you're developing a game that interacts with your room. Last two things are optional, but you're going to need one or the other in order to test the game. You may need the HoloLens emulator, which is going to need to run on Windows 10 Pro because it uses Hyper-V. Or you can get the HoloLens Dev Edition, that's this thing, for only $3,000, and you can buy it from the Windows Store, from the Microsoft Store. Okay, so instead of actually trying to do this live in front of you, which would be incredibly painful, I'm going to give you a taste of it and just walk you through the experience of building the game. First thing, you open up your special HoloLens edition of Unity. You're all familiar with this screen. And there's some very simple things. Now, I love the shot because this sort of explains the core of how you take any Unity game and turn it into a HoloLens game. The camera itself is you when you've got the HoloLens on. So a few things you immediately need to do: put the camera at coordinate 0, 0, 0. So that everything else is spinning around you. You're at the center of the universe with the HoloLens. Can't have a skybox. The way the HoloLens SDK and HoloLens works is the color black is transparent, as with a few other systems. So what you need to do is set the background to a solid color and set it to RGB 0, 0, 0. Final thing is optional, but also a really good idea. You want to set the clipping plane so that anything closer than 0.85 meters is going to disappear. There are a few reasons for this. One of them is that for some people, it's going to cause you to be dizzy if objects are too close and you're trying to focus on them. A second thing is you can't actually interact with these objects directly at this point. So it would be very frustrating to have an object closer than that and you're constantly swatting it and nothing happens. So a clipping plane of 0.85 meters is pretty cool. Okay, so next thing you want to have is a 3D model. So I went ahead and went out to the Unity store, grabbed the first thing I saw that was free, and dragged it into my project. And of course, you just drag it into the scene view. And again, this is just the most basic HoloLens demo you can do. But I'm going to put it offset just a little bit, about 2 meters away from me. The original object wasn't big enough, so I just increased the size a little. And that's pretty much it. Now I've got a 3D object in my HoloLens AR world. Okay, so here comes the fun part, and this is where all the pain happens, because you've got to export your Unity project for Visual Studio. So there's a bunch of settings you need to go through. First one is you want to be using Universal 10 SDK. You're using D3D. You can use XAML. There's some arguments online about the advantages and disadvantages of each. and it's going to be a C# project, and you're going to be deploying to the Windows Store. Okay, this is key. As far as I can tell, probably tens of thousands of dollars have been wasted by HoloLens developers so far because they forget to check off these boxes and then spend 5 hours trying to figure out why they can't deploy, why their HoloLens game doesn't work. And it's because you've got these settings that you've got to click through to find, and just remember, check it off. One of them is to activate the capability of spatial perception, which just means this is going to work on HoloLens, right? And another one is to go ahead and pull in, to check off virtual reality so that you can pull in the Windows holographic libraries. 2 really simple things to enable your Unity game for HoloLens. And then the final thing you do is go ahead and export it off to Visual Studio. So then you go ahead and hit build, have to specify a new folder. It creates a whole solution project for you. Okay, and you end up with the Visual Studio project. And then you have to go through some more configuration. So you go into the app manifest. I'm not putting this down. It's just this fascinating long process, and I love doing it every time. You don't actually open it in the IDE. You need a text editor to open it up. Yeah. So that you can go through and change Windows Universal target device to Windows Holographic. And actually, this morning when I was putting this together, I mistyped and had holographic, and spent half an hour trying to figure out why wouldn't this compile. Yeah. And then that's it for that. Okay, so that's pretty much everything. At that point, you've got a game ready to go. You go into Visual Studio, and here's some very key settings. Generally, you want to set it to master build, and this is a weird world of Unity going to Visual Studio, where Visual Studio has release builds and debug builds, but then for UWP apps, there's this extra setting, master builds, which is much faster, more efficient, throws out analysis code. So you want to do that. x86, because fascinatingly, the HoloLens uses an Intel 86 chip. Why not, right? You want to do 2 things, either target the virtual emulator or target the remote machine, which is your HoloLens, in which case you need to configure it and sync them up so that there's a trust relationship between them. And then you control F5, and then you go get a coffee. And now we're just going to have 5 minutes of silence to emulate that experience of waiting for it to compile. That's cool.
So where's the coffee?
Right? I was going to ask you that. And voila. So this is what you end up with, that chess, and we'll just do the side-by-side. I mean, pretty straightforward, right? You import a 3D chess into your game, spend a lot of painful time checking off things and forgetting to check off things, and eventually you deploy it to your device, and you've got the object there. So the next thing I'm going to try to do is see if I can do a live cast from this. Sometimes it works, sometimes it doesn't. I'm actually going to put it on.
I mean, he's on GT Wi-Fi. It's super reliable, so.
Is it actually working? I forgot.
I see it on your screen. It's amazing.
Oh!
Yeah, it's on your screen, but it's not on the projector.
I'm so sorry. Let's see.
Windows P. Yeah.
Yeah, yeah. You know, who's to say? There it is. Sasha.
Okay, so to end the panel for the day, we're just going to talk about a little bit about what we've been doing in mixed reality in our lab for games. And so again, this is the group that's been working on the set game that I'm going to be explaining again. Tristan's here, Cheng's sitting here too as part of BG So what was our objective? Our objective was to actually see whether we could use artificial intelligence and procedural content generation to make mixed reality games more compelling to the users. Can we increase the reusability of the game? Can we actually take into account things like what is your furniture configuration, or do we want the user to walk around a lot, or do we want them to just sit in one place and play the game? And so we had all these design constraints, most of which I think Kristen kind of covered, which was, well, first of all, we didn't have the HoloLens for like the longest time. And so we had to make it device independent at the moment. So right now we have the game running on a simulator. We also we had other concerns about the world, how much knowledge we have about the world around us. So again, room detection is a super hard problem. We had to figure out surface detection, we had to figure out what kind of rooms we were in, and can we actually change these games, adapt these games to the different rooms. And another issue we had was, again, occlusion. So how do you handle for the fact that certain parts of the sofa are not really visible to you? So if the arm of the sofa is kind of hiding parts of the sofa, does that mean that my virtual character is just going to go and then just fall through that little thing? And so the way we did it is we kind of broke up the project, and I'm assuming this is how a lot of you are going to be doing this as well. So we initially handled the entire depth data or the surface detection using Kinect. So we had Kinect Fusion scan the entire room. We found all the flat surfaces that we wanted to play on. Then we had our AI system be completely different from the actual application in the game. So the AI would figure out what surfaces we wanted to use. It would figure out the parameters of our game, like we want the user to walk around a lot or whatever, however the difficulty had to be mapped. And then once we had the entire game, we kind of made like a little JSON file that said, okay, this is the route for little Mario to walk around on, or Lemmings. And we sent that to Unity, and Unity would kind of implement that. So just quickly again, so this is basically the room that you're going to be seeing. This is our lab right now. And so this is what it looks like once Kinect Fusion has done its stuff. And so you really can't see right now, but a part of this model is going to be actually all hidden. So anything that Fusion couldn't see, so stuff behind that pillow, or a part of this armchair you won't really see. And so those are actually holes in our game, and these are things you'll have to take into account later. So we figured out surface detection and found like interesting surfaces that we wanted to play on. So I looked at like the area of the surfaces, so really tiny things that were on tables and stuff at the back over there would just not be used. Then we figured out which surfaces our character could kind of jump to and from. So if surfaces were close enough, we would let the character just maybe jump from one to the other. If they were really far away from each other, then we had to then tell our game that we now need like a virtual platform of sort between this surface and the next. And then we came up with two games that we built around the same space. So the first is really loosely inspired by Mario, where we have basically the little tiny Mario character, I don't know whether you can all see it, jumping from one surface to another. We gave him enemies, so here you can see two enemies, a pencil and a book. So what the eventual objective will be is if you're in the living room, maybe you have enemies that are kind of more suitable for your living area come and attack you. So right now the book kind of flies over him and then just tries to smash him or fall on him. And the pencil just follows him around and tries to poke the little character, and so you have to jump over those. And maybe if you're in a kitchen, you could actually have virtual knives come fly at you from all directions. And so again, you can see how the game would change over time based on where you are and what kind of rooms you're in. And The second one we did was Lemmings. How many people here actually played Lemmings? It is just really cool, awesome, because the last time I did this, no one played Lemmings. so we actually made, like, using the same surfaces, we made Lemmings. And so the difference was that while Mario was restricted to a single track, where we could actually control what surfaces and what order Mario visits, we let Lemmings be more of a continuous movement within the surfaces. So while we told the Unity game that we wanted these surfaces to be visited, we actually let the player put direction boxes currently in virtual reality, but eventually we're hoping to tie up real boxes and items you put there to kind of redirect your character. And we have like these jump pads which let the lemmings just stand there and then jump to the next surface. And so what we did to ensure that you go in the direction that we want you to go is we have virtual walls set up which kind of stop you from going between surfaces and taking, like, Pythagoras shortcuts through our game space. And so this is more or less what it looks like. We have some settings about how much we want the human in the environment to actually move. And you can kind of see the game being generated. And there you go. So you can see all the holes in the environment where our surface detection went off, but yeah. And so you can kind of see that in order for the player to reach certain parts or like put the large jump pad, he actually has to walk around the furniture. And so we could make these really interesting heuristics where we could actually define, so the green dotted line is the player moving through the environment and the blue line is what we're hoping that the lemmings will travel through. And so we could actually do things like say, okay, we don't want this user to move at all, and so maybe the user is, depending on where he is, he just has to turn around and the surfaces are all around him. Versus if we want the user to walk around a lot, maybe first send him to one side of the room and then send him to another side of the room and make him change rooms, and you can do whatever you want there. And so that was really interesting. And so our future research direction would also be maybe tying up with, how many of you know about like the Aware Home that Georgia Tech has? Okay, a few of you. So Georgia Tech has this really smart home on 10th Street where it's so smart that it's a little creepy. It knows exactly where you are in the room, it knows what tile you're standing on, it knows what room you're in. When you go to the bathroom, if you look in the mirror, there are all these statistics that will show up. It will tell you your sports, games, and whatever details that you follow. It knows what time you wake up, it knows what time you sleep, it can put coffee on for you, it's ridiculous. So you could actually use that kind of data from the whole IoT world that we're kind of stepping into to really, really customize your game. And so that would be something that we could look at in the future. And so what are some of the other questions that you guys can actually help solve now? So again, as I said, mixed reality is really, really fun. And we are completely living in this brilliant sci-fi world where everything from Back to the Future and Asimov is actually coming true. And so here are some of the things that are actually really interesting to look at. So one is like the simulation hypothesis. Are you actually living in a simulation? So this is something that was actually 5th century BC by Buddha, but got into Western culture with The Matrix and The Truman Show, where, is the user wearing the HoloLens always going to be looking for where the simulation ends? Where's the green grid at the end of the world? And so can you actually fool the user and have objects that are so complicated or so amazing that they look like they're actually a part of the world? Can you actually integrate your virtual objects in such a way that it would be very difficult to identify what's real and what's virtual? So for that, our lab right now is exploring the PCG and AI versions of this question. So we're looking at real world constraints. So if there are actually people in the room, how does that change your game? In a virtual world, you can control who is around you. You can control where the person goes. How do you actually have these realistic integrations? There are labs around the world that are working on relationships between objects. So if you identify a table, can I then say, I will put a lamp on the table and not on the ceiling? Or other reusability or object placement semantic rule challenges. Another question that would be really cool to answer would be, what is the extent of world knowledge that you need? So if you look at the world, you can see from the graph at the bottom, you have a completely unmodeled world and you have a completely modeled world. So if you know nothing about the world, or maybe you just know what you're seeing, versus knowing what the weather is like, what the time is like, where is this particular room located, what kind of room is it? And so how would that actually change your game, your knowledge of the world? So that's another really interesting question. And in games, that becomes even more important because the state of your own game world could change on the basis of that. So if you modeled your world perfectly, or if you can make really good inferences about your world, then your new state is going to match what the actual state of the world is. You move the table and your game has kind of compensated for it. Versus if you've not modeled the world really well, so you tell the user he has to move this table, but it's actually nailed down to the floor. And so now, how does that change the world in your game? Next is reproduction fidelity. So basically, how good, this is again a CG limitation, a graphics limitation, a device limitation, but how good can you, what kind of objects can you implement within the world? So can we actually eventually reach the goal of, the holodeck on Star Trek? And that would be so cool. But are we going to start with maybe wireframes and eventually go to proper 3D animation in real time, in high res, with haptics? And so that would be another interesting thing to look at. And finally, almost finally, there's the extent of presence. So to what level are you going to be a participant in this world? So are you going to be just an observer, where maybe you have a particular 3D video running, or you're watching your television on the HoloLens on the wall? Or are you going to be an active participant, in which case now we need a fully immersive world. We need to know how that world is going to interact, how you should actually come up with new ways of interacting with these virtual objects. And finally, player choices. So in the virtual world, in any game that you've ever created or played, you have a complete control over the world itself. If you don't want the player to go into the secret room right at the beginning of the game, you can put a lock on that room. Here, the player is just going to walk through this fake lock that you generate and walk into the next room. And so how do you kind of look at generating narratives or stories in your game, and how do you kind of push them to go in the direction that you want to go? So for instance, if you have this map of Georgia Tech and you want them to explore it, how would you actually structure your game over, like say, a Google map, to make sure that the character goes in a way that makes the story more relevant to the game? And so I genuinely don't know what's next in this field, and it is really fascinating because we're at the very start of it all. And I'm really hoping that all of you guys are going to be tackling different issues and problems that we have in this field. And hopefully one day soon I can walk into a room and then there would be a TARDIS that appeared there, and then you walk towards the TARDIS and suddenly you're in, I don't know, there are dinosaurs everywhere. And that would be an epic way to go about your research with the HoloLens. So that's about it from us. If you have any questions, you can walk up to any of us and we will try to answer this.
All right, guys, so we're going to do a few minutes Q&A, so if you guys have any questions for the panel, go ahead and raise your hands and start calling you guys out.
And also, I know there's some questions on the internet. So
Yeah, I know I've got one on the YouTube channel.
Do you want me to ask it, and then if we don't understand, so the user No One Knows Nothing says, are any APPs small or demo development done? And if so, what will be the difficulty level for a 5 years experienced developer?
I think they meant apps, right?
Apps.
Yeah.
It was capitalizing.
Cool.
I feel bad. I was about to ask what's an app and then feel really foolish.
Okay. Do you have an answer to that question? So any apps or small development, any demo code available for HoloLens, basically? And how hard would it be for somebody with 5 years of development to pick up HoloLens stuff?
It depends on what your development experience is. If you're a Unity developer, you're set. If you're a Unity developer who's been doing virtual reality, you're really, really set. If you're a C# developer who's been working on enterprise apps in Visual Studio for the last 5 years, you need to go learn Unity. And then you'll be good. And part of it is learning an ID that lets you develop these games, but the bigger trick is learning the concepts behind 3D, right? So if you've got the concepts, you're most of the way there. And then the final thing is some experience with 3D sensors like the Kinect. So you understand how basically all of this is being pulled together for you with the sensors and what sort of issues like occlusion you need to look out for.
And I think it's really good, the audience here, you guys are all game developers, you know what it's like to make games, you understand 3D and a lot, and because now we're looking at the world in 3D, having that experience is really, really valuable, so that definitely helps a lot.
All right, does anybody else have any questions here in the room? I can answer this one off of the YouTube chat. So Rodrigo, yes, they are planning to expand the field of view. That's no limitation. And I think that's pretty much it. So Andrew, I think we got some I'm sorry, back in the room. Sorry, y'all.
Oh, you go first. And repeat the question if you would so we can broadcast.
Got it on watch.
So I was just wondering if, as an undergrad student, if I was interested in joining the intelligence and independent development lab, is there like a website we can check out or something we can look at?
Repeat the chance to advertise what you do.
Okay, so the question was, the question was, if I'm a student and I want to look into joining the Entertainment Intelligence Lab, which is where Sasha and I are from, how do you get involved? Well, you can Google it. Mark Rydell is the professor here at Georgia Tech who runs the lab, and we've got a bunch of undergrads and we've got a bunch of master's students and PhD students who are working on it. So just drop by our lab. We live in the School of Interactive Computing over in TSRB, the Technology Square Research Building. And just, we've got a lot of different projects related to narrative and games going. So if you're interested, just come by.
If you walk in during Mark's office hours, you can just talk to him about anything you're interested in and figure out whether that's a good research thing that you want to do.
If you're a CS student, he teaches a game AI class that's pretty pre-med. So put that on your docket.
And since tonight's also brought to you by Microsoft, you can Bing it as well.
Okay, cool. And then last question here in the back. What was your question?
I just wanted to know, since it's still in the development phase, what's the time period between SDK client releases on, I think it's GitHub that they posted on, or maybe it's their site. I don't know if they have a regular release schedule for their SDKs or not, or if they just have the one for
right. So there's a question about the release schedule for the SDK and the dev kits. So one correction, the dev kits have been out since about April, but right now Microsoft is also has released a commercial version for enterprises, not a consumer version, but a commercial version where you can buy them in bulk. SDK cadence is basically, there have been 2 releases. You had one around April and you had another one in September.
Right.
So far that's the cadence.
And see, those are the 2 I know, so I don't know if there's like a secret one that I haven't found. Where they do like stable release, dev release.
Not that I know, not for everybody. There are obviously first-party partners of Microsoft's who have access to more. There's probably a handful of those, but for everybody else, no.
I feel like this is something that if you were part of the Windows Insider program, there might be some stuff to look around there. I actually have no idea. I mean, it's not just, again, this is just the SDK. There are like other tools, out there. So like Holo Toolkit, which is up on GitHub, is a bunch of code that Microsoft worked on and released. So like all of the stuff that takes the service reconstructed mesh and turns it into planes, that got released, and they don't seem to have a pretty regular schedule for that. So I know like the people who are working on Young Conqueror apparently released all of their room recognition code very recently within the last couple of months. So I hadn't taken a look at it in a couple of months, and I looked at it just the other day and was like, wow, it's like up there.
Yeah, that was like 2 weeks ago.
Yeah, it was very, very recent. So like, that they're still turning out stuff for that. And I know there are people that are committed to keeping that open for developers to use.
Okay, so actually one last question because you were hidden behind me and I feel bad. So what's your question?
Kind of 2 questions. So one, last time I checked, Hyper-V is still needed for the development of Hololens. Is that still true?
To run the emulator.
Repeat the question real close.
Yeah, it's about do you need Hyper-V in order to work with the HoloLens? Only if you're running your projects on the emulator and testing them there, but you can also just send it straight to the device if you have one.
Okay. And extending upon that, developing with either HoloLens and emulator, the compile time takes really a long time, like you mentioned. Is there like a suggestion or any tips on making it faster?
You need to write a letter to Microsoft.
So a couple of things just to think about, which are like, again, you're taking this, there's this process of taking a Unity project and putting it into, turning it into Visual Studio Project, which you then package up as a UWP app on the device, right? So all of the optimizations that you would be normally making for your game, so like reducing your poly count as much as possible, downsizing your textures, making them powers of 2, just small things like that will definitely help, because again, this is a device, you're packaging up a game, right? So any kind of optimization you can also make on the game side is definitely going to help your compilation time.
Oh, sorry, one more question. So when I was developing an app for the Hololens, I noticed that it works on Unity, but not the Hololens, and it'll crash specifically on the emulator, and sometimes even the Hololens itself. So is there like a way of debugging that? Because sometimes when it just crashes, it doesn't really tell you much.
I mean, you can debug on the device itself, right? You can run it in debug and then put breakpoints in the script. And again, part of the trick is it's 2 sets of technologies coming together. It's everything Microsoft built in order to deploy Unity games on UWP, and then hijacking all of that to make it work for HoloLens also. But yeah, you've got really powerful debugging features with Visual Studio. That may help. It depends on what the issue is. And sometimes it's just running out of memory. And a very common thing I remember in, say about 3 months ago, is you would have random crashes, in which case just turn off your emulator, turn off your device, start them up again, and try again, right? So that's just, it's early days, that's where we are right now.
The best kind of bugs.
Okay, cool. So I think we're going to wrap up. Andrew, you got some last announcements?
Sure, Ron, I know you got stuck away. I want to introduce the head of our indie cluster, faster. So we mentioned Siege. We have these flyers for Siege, so please pick them up on your way out. Ron Jones, who is slowly making his way on around. Ron runs our indie cluster. If you have a game that you would like to show off at Siege, talk to this gentleman right here, and he'll have more information about it. He's also involved, like we said before, in the design for independent games, or the award for independent game design excellence. So he'll be talking about that.
Sponsored by Puzzles by Joe.
Puzzles by Joe, exactly. And I'm sure I had more, but I'll let you.
Okay, so 2 last things. I told you I was going to give away some goodie bags. So Tika Lynn, are you in here? Tika Lynn. Okay.
Must be present to win.
Jessica Sui, TSUI. All right, you win some stuff. All right. I'm going to pick somebody random. Chris Purdy, are you in here? Hey, you win some stuff too. So you 2 come see me right after this. Okay, and I think that about wraps it up. So once again, shameless plug. Please follow Microsoft Student Partners on social media. That's how they got free stuff, because they did that.
Thanks to the Institute for People.
Yeah.
The Institute.
The Institute for People and Technology. Yes.
There we go.
So big thanks to them for hosting this, and for our speakers. Thanks for coming out and give us this awesome presentation. So thanks everyone for coming out.